This is lesson number 90, Algebra 2, Systems of Three Equations. Now it seems like, I know we did these earlier. Let's see, it must have been, I'm looking here in my book real quick. Gosh. Anyway, it was back in the 40s or 50s lessons where we did three equations. Well, we're going to continue along with that. And let's just get started here by looking at the first example. The most common procedure, it says in bold, is to add two equations so that one variable is eliminated. Then the remaining equation is added to one of those already used so that the same variable is eliminated. The result will be two equations and two unknowns. Alright, so that's what we're going to do. So let me write that down. Okay, so there it is. And what we're going to do is we're going to try to eliminate one of the variables. And I think probably the best one to eliminate is the z. So if we look at these two right here and just add them, what's going to happen to our z's? They're going to disappear, aren't they? Because we have a positive z and a negative z. And 2x minus y minus z. So let's add those. Those go away. Okay, so now we have one equation with two variables. Alright, let's look at the other one that we didn't use, and we're going to add that to one of these two. Doesn't matter which one, but I'm going to add it to this one and get rid of my z's again. Okay, so if you get rid of the z in the first one when you're combining, you have to get rid of z in the next one. So we're going to take these two and we'll add them, and I'm just going to add them where they're at. So I get 4x minus 3y, those disappear, equals 1. So look what I've got here. I have an equation here with an x and a y, an equation there with an x and a y. I know how to do that. 3x plus y equals 4. 4x minus 3y equals 1. And let's see, let's get rid of the y's. So I'm going to multiply the top by 3. So I get 9x plus 3y equals 12. 9x. And I'll leave this one alone. Okay, notice what I've got here. Add those up and I get 0. So x equals 1. Okay, phew. That's the hard one. Once you find what one of the variables is, the rest of it's easy, because now I take this and I plug it into this equation or this equation. Doesn't really matter which one. So let's plug it in over here. 4 times 1 minus 3y equals 1. So 4 minus 3y equals 1. Subtract 4 from both sides, so y equals positive 1. Okay, that's the next hardest one, is to find that. Now, I take my x and my y, being 1, and I go over here and pick one of these that has all three variables. So once I find out what my first variable is, I plug it into one of my two variable equations. Doesn't matter which one, this one here or this one. And then now that I have two answers, I take those and plug it into my 3. So I've got 1 plus 2 times 1 is 3, plus z equals 4. So z also then, when I figure that out, equals 1. So there are all three. Those are called triplets. An ordered triple. Alright, so that's it. We're going to do one more, and then we will call it a day for lesson number 90. And we are cruising along in this book. We're getting further along in this book than we normally get at this time of year. So this is good. Okay, so let me put that example down, 90.2. Okay, so now what we're going to do is we're going to pick two equations of these three and see if we can eliminate a variable. Well, here we have a plus 2y and here we have a minus 2y. So let's add these two right here. In fact, let's just leave them there and add those. So we have 2x. Those go away. Notice my z's have a line, my 2's don't, so this is a 2, this is a z. 8 plus 0, 0. There, now I have two variables in that equation. Okay, so now let's look at another two equations and see if we can get rid of another y. So let's take the, you know, it doesn't really matter. Let's take the first and second one here and get rid of the variable there. So we have 2x minus y plus 3z equals 9. What did I say, the second one? Okay, so I got rid of y over here in this one, so I have to get rid of y in this one here. So I need to multiply the top by 2 so that this becomes a negative 2y, and I can add these and get 0. So let's put this right here. 4x minus 2y plus 6z equals 18. And I'm just going to rewrite the bottom. Let's add these. Those go away. So there's another equation with just an x and a z. So now I put these two together. So let me bring the 2x plus 2z equals 8 together, and that's the one I'm going to look at now to find either the x or the z. Let's see. So if I want to get rid of the x, that means these x's have to be the same. So this has to be a 10 and that has to be a 10. In fact, we'd make that a negative 10 and that a positive 10 so that they cancel. So let's move all this up. And we want to leave this alone. We're going to move that down there. And try to clear some space here. Way too much space to clear. Alright, so let's get this and move it over here. Alright, so we're interested in just this right here. Alright, so we're going to multiply the top. Let's multiply the top by 2. And let's multiply the bottom by negative 5. And that'll give us a 10 here and a 10 here that'll cancel. Alright, so the top will be 10x plus 14z equals 52. And negative 10x minus 10z equals negative 40. So those go away. That becomes 4z, and that becomes 12. So z then equals 3. Okay, so we found the 3. So let's put that over here. Z equals 3. And we can get rid of all of this now that we already found it. And we still have, in red and blue, we have our two original ones. And we can pick either one of these to plug 3 in. So let's go ahead, whoops, wrong way. Let's go ahead and use the top one. 5x plus 7 times 3, my z. So 5x plus 21 equals 26. 5x equals 5. X equals 1. Okay, get rid of that. And actually, we don't need any of this stuff anymore. Now we have 2 of our answers. We go back up to our 3 problem one, and let's just pick the top one. We put 2 times our 1. We don't know what our y is, but we know our z is going to be that. So we have 2 minus y plus 9 equals 9. And 2 plus 9 is 11. Negative y equals negative 2. And then we just switch the signs. And we have y equals 2. And we just found all 3 variables. Okay, so it's just getting the hang of it. So follow these instructions, you should be just fine for lesson 90.